Hello and welcome to this video. I want us to learn about the product rule. Now, the product rule is another technique of finding derivatives, and we're going to look at examples of functions that can be differentiated using the product rule. Now, the product rule is used to find the derivative of a function that is a product of two other functions, or it's a multiplication of other functions. For example, if we have a function, let's say f of x is equal to, let's say 2x plus 3 and 4x plus 5. Okay, one can decide to use the product rule to find the derivative of such a function. Well, one can also decide to open the bracket and then use the power rule to find the derivative. Both cases will still work, but in this case we will find the derivative of this function using the product rule, just to demonstrate the product rule, but one can also use other methods to find the derivative of this function. So what does the product rule states? Now, if we have a function that is made up of two other smaller functions, let's say it's f times g, just like we have this times this. Let's say it's f times g. So the derivative of such a function will be found by having f prime g plus f g prime. So what is f prime and what is g prime? Now f prime is the derivative of f, okay? Just the f part, this part, okay? And then g prime is the derivative of this second part. So let's try to follow this formula and try to work out the derivative of this function here. So in this case, our f is 2x plus 3, and then g is going to be 4x plus 5. Okay, so let's find f prime and g prime. So what is f prime? So as I have said, f prime is the derivative of f. So let's differentiate f. So with respect to x. Okay, so 2x plus 3. So when you differentiate this, it's going to be 2. Okay, remember we did this using the power rule. So this is 2x to the power of 1, and then so it's going to be 1 times 2, which is 2, and then 1 minus 1, it's going to be x to the power of 0, and x to the power of 0 is 1, so it's 1 times 2. So the entire function becomes 2, since the derivative of 3, which is a constant, is 0. Okay, then we have the derivative of g. It's going to be 4. So we have f prime and we have g prime. So we now replace these values to our formula that I've just written. So the derivative of f of x, maybe I can denote it as f prime of x. So the derivative of this function is going to be f prime, which is 2, we multiply by the value of g. G is 4x plus 5, and then we add to f times g prime. So it's going to be 4 times 2x plus 3. So we can open the brackets. So we're going to have 8x, okay, 8x, and then plus 10, and then plus 8x and then plus 12. So when we simplify this, 8x plus 8x is going to be, it's going to be 16x, and then plus 10 plus 12 is going to be 22. So that is going to be the derivative of that function using the product rule. I want us to confirm whether this is actually the correct answer, and the way we are going to confirm it, we are going to use the product, not the product rule, but the power rule to find the derivative of the same function, and then we confirm whether the answer is correct. So what we're going to do, we are first of all going to open these brackets. So maybe I can use a different color. Let me use blue. So we have 2x plus 3, 2x plus 3, and then 4x plus 5. So you can first of all pause the video. Maybe you can try to work it out by yourself, and then you can confirm whether the answer is correct. So when you open this bracket, it's going to be 2x multiplied by 4x plus 5, and then plus 3 multiplied by 4x plus 5. So this will be 16, or not 16 but 8x squared plus 10x, and then plus 12x, and then plus 15. So we can put like terms together. So it's going to be 8x squared plus 22x plus 15. So now we can use the power rule to find the derivative of this function. So it's going to be 8 times 2 is 16, and then x, and then plus the derivative of 22x is going to be 22, and then the derivative of 15 is going to be 0. So you see, we have a similar answer. So you see the product rule has worked for that case. Now let's try to look at yet another example. Let's have x and then exponential x. Okay, so we can call this function v. Let's call it v. So we have a function v that is x times exponential x. So let's try to work out the derivative of this function dv over dx using the product rule. So let me write down the product rule once again. So we have f prime g plus f g prime. Okay, so let's now identify the value of f and the value of g, and then find f prime and g prime. So in this case, let's have the value of f as x, and then g is going to be exponential x. So we can now find f prime and g prime. So f prime is the derivative of x. When we differentiate x, we get 1. So it's 1. Okay, let me write this one properly. So it's 1, and then g prime is still going to remain as exponential x, because now the derivative, okay, the derivative of a function, maybe exponential u, is supposed to be exponential u multiplied by the derivative of u. So in this case, u is x, so the derivative of x is 1. So it's going to be 1 times exponential x. So that's why it's going to remain as exponential x. So we can now replace these values to our formula here, so that the derivative is now going to be f prime, which is 1, we multiply by g, we multiply by exponential x, and then we add to f times g prime. So f is x and g prime is exponential x. So this is going to be exponential x plus x exponential x. So we can maybe simplify this by factoring out exponential x, so that we have 1 plus x, and that is now going to be the derivative of our function there. So let's try to work out yet another example. Let's say we have x squared and then exponential 3x. Okay, we have a function, we can call it u. Let's find the value of du over dx. Rather, let's differentiate this function. So you can probably pause the video and try to work it out by yourself and see whether you're still on the right track. So let's identify f and g, and then find f prime and g prime. So our f is going to be x squared, and then g is going to be exponential 3x. So f prime is going to be 2x, okay, and g prime is going to be 3e raised to 3x. So as we said, if we have e to power u, the derivative is supposed to be e raised to u multiplied by u prime, or the derivative of u. So for this case, we have e raised to 3x. The derivative is going to be e raised to 3x, or exponential 3x, and then we multiply by the derivative of u, that is 3x, which is 3. So this is going to be 3 exponential 3x. So we now replace these values to our formula, that is f prime g plus f g prime. So we have f prime as 2x, we multiply by g, which is e raised to 3x, and then we add it to f. We have f as x squared, and then we multiply by g prime, which is 3e raised to 3x. So we can simplify this, and we can factor out we can factor out x, and then exponential 3x, it's common for both cases, and then inside the bracket we're going to have 2, and then plus 3x dx. So for all the cases we have a dx here, and that is going to be the derivative of our function here. So I see we are running out of time. In the next video we are going to learn more about the product rule. We are going to look at more examples of how we can solve the derivatives of such functions. So let's meet in the next video.